Hi, it's Robin. My friend Jason recently told me about an interesting new release on CSDB. It's just Epic's Championship Wrestling. What's interesting about it is the directory. I'm just going to hit the directory now. I'm using Super Snapshot, so this is a wedge. If you just type $, it'll show the directory on the screen. And check this out. Yep, that's a couple guys wrestling in the disk directory. Grappling headbutt. And the guy wins. I don't think I'd ever seen anything like this before, an animation directory. I've seen weird directories over the years. People do various tricks to modify a disk directory, but that's the first time I've seen that. One more time, just for fun. And notice how it said delete. There's a couple little oddities about it. Above and below the wrestlers, there's lines that say DEL. So I think that's a clue as to how this works. You can actually just load the directory like a normal one. Load $8. And you see it takes a long time to load. So I think that's also a clue as to what's going on with this directory. And we'll list it. And it'll play back, but it'll be faster than before. Because the directory isn't streaming from the disk, it's all in RAM already, and that's just being printed out. So it still works, but it runs a lot faster. I think it's intended to be shown with a wedge where the directory is loaded or displayed non-destructively instead of loaded into memory. So of course, I'm not happy just showing you this. I want to figure out why it works and even try and make my own simple animation. I'm not going to try anything as ambitious as this, but a little proof of concept. That's going to require us looking into directories and how disk directories work on the Commodore 64. I knew some of this, but for this episode, I actually had to do a lot of new reading. So I have a copy of the 1541. It's called the 1541 User's Guide. It's not official, though. The Complete Guide to the Commodore's 1541 Disk Drive by Dr. Gerald Neufeld. This is a really good book. Presumably you can find it online somewhere as a PDF or whatever. So we will take a look at this disk, but first, just so it's simpler, I'm going to take a fresh disk. And I'm just going to format this. You can use the regular format command, the new N command, but my cartridge also has a fast new built into it, so we're going to use that. It formats a disk much quicker, and we'll just do a directory. And I'll just skip ahead here. Okay, so there's our disk. I'm going to go into the Super Snapshot monitor, and probably most utility cartridges give you some way of looking at the disk drive as well. On here it's called the U1 command, and you type in U1 to load a block, or to load a sector off the disk, and the directory on a 1541 disk is on track 18, but that's hexadecimal 12. We'll just be using hex today, rather than me jumping back and forth between it. The first sector on track 12 is the directory. So, okay, it's loaded into memory. It defaults to load into C1000. So that sector is now in Commodore 64 RAM, and we can take a look at it. And here's the sector. It's 256 bytes. So it actually goes all the way from C1000 when it's in RAM, all the way down to CFF. And then this is the end. This is the end of it right here. So let's just take a look through the directory. And so at C1000, the first 2 bytes of any sector have a pointer to the next sector. Now from 12.0 to 12.1 is obvious, but you shouldn't assume that next will be 12.2. I think it's usually 12.4 that's next. There's an interleave, and the tracks aren't necessarily used in numerical order. There are other considerations such as the rotation and the time that it takes for the drive to read and process the information. By then, the disk will have rotated further. So the first 2 bytes of the directory just point to the next entry in the directory. Then this byte, hex 41, that indicates the DOS version that this disk is using. And I've experimented with that. I can change that byte, but if you change it, you can no longer write to the disk. And it seems I can't even write to correct that mistake. So if you change this particular byte, that disk is done for. Basically, I just had to format it again. There's probably some tool somebody's written to fix that, but I wasn't able to do it. The next byte is unused, and then the next 4 bytes, these ones here, are part of the BAM, the block availability map. This shows that there are 15 hex blocks available. Blocks and sectors are almost interchangeable, so if I say the wrong one sometime, go easy on me. 15 hex is 21 decimal. There are 21 blocks available in this first track. And then the next 3 bytes are a bitmap showing what blocks are available. And it actually goes kind of strangely. The least significant bit, sector 0, 1, 2, 3 in this nibble. Then the high nibble has 4, 5, 6, 7. Then this has 8, 9, 10, 11, 12, 13, 14, 15. And here's 16, 17, 18, 19. And finally 20. There's 21 of them, but they're numbered 0 through 20. It's 0 based. And then this pattern just repeats. This is for track 2, track 3, keeping track of what space is available on the disk. You get all the way down to here, and there's 15, so it's 21 sectors per track. And here is track 18, track 12 in hex, which is the directory that we're looking at right now. And there's actually less free, and that's because the system reserves a bit of it for its own use. So that's why there's only 11, that's 17 sectors free. And then you go next, after the directory track is over, this is track 19 decimal that we're on now, there's only 13 free. If we keep scrolling, we see that there are 13, 12 sectors as you get near the end of the disk down, and the very last track, 35 tracks total, only has 11 hex, that's 17 sectors available in. That's because you got your disk, the outside of it is actually larger, and as you go work your way in, there's less physical space for the sectors. Many other disk operating systems, early disk operating systems, would actually just have the same number of sectors per track, but that was actually wasteful. So this is actually kind of an advanced feature for the early 1980s to have a variable number of sectors based on what track you're in. So Commodore DOS, it's not perfect, but it had some neat ideas in it, and this is one of them. And then after the BAM that's the end of the BAM. There's just a few more rows here. The next one is the title. So we called it test. You can see over here on the right, it says test. And here's the PETSCII codes for that. And then the rest of it is padded with these A0s. That's a shifted space in PETSCII. And it's 16 characters long. And then there's a bit more padding. And then there's some codes here. I typed in T1 as the identification on that format command. It's just a 2-letter or number ID. And you see it gets encoded here as in PETSCII. And then there's a shifted space, another A0. And then 2A, I believe that's called, the cosmetic disk type. And every 1541 disk says 2A there, but it doesn't actually use it in any way. It just tells the user that. So actually, here's a neat little hack we can do. You might have seen this one before. If you look at memory, so that T1 starts here at location C0A2. So we can modify that, C0A2. And instead, we can type 8-bit, like this. And now let's look at memory, where we just modified it. Okay, see how it says it there? And now we're going to save this back. The U2 command saves to disk. You have to be very careful when you do this, by the way. Basically, do not do this to any disk that has important information, because if you mess up, it's gone. So we'll save that. And now we'll go back to basic, and we'll do a directory here. You see how it still says T1, this actually caught me. I thought I had written it and the change hadn't taken place. All we have to do is pop the disk out, put it back in, and then do a directory again. And there's the change. So you can actually modify these disks. Commodore DOS doesn't appear to care about some of these. They're just cosmetic, so you can modify them. I've seen people put some pretty weird stuff in this header on the disk. Okay, now while we're here, do we have anything in directory? Yeah, okay. I'm just going to save a couple files. File 01. File 2, and we're just doing this as an example. Okay, so now we have 3 files, and we don't really care about what data is in them. We're just looking at the directories today. So I'm going to load that directory back in. Like I was saying, you look up in the top first 2 bytes show the next track and sector to jump to. So we're going to load that, 12.1. And we're going to look at that. And here we are. So the first 2 bytes always point to the next track and sector. If there is no track and sector, like we're at the end of the directory right now, it'll have a 00FF in these first 2 bytes. And if you look over on the right, you'll see that file 1, file 2, file 3. That should make it easy for you to see that each directory entry gets 4 lines to itself, 32 bytes per directory entry. Here's one, here's the second one, and here's the third one. File, you see over here, file 1, 2, and 3. So let's just look at what each entry says. After the first 2 bytes, so this 82 is the file type. This book actually has a list of them all. You see here, hex 82 decimal 130 is a PRG file. And that's the most common file that you see. That's what most games are and so on. And you can actually just modify the file type right here if you wanted to. We're not going to do that right now. And then if we look here, this is the track and sector, track 11 hex, sector 0, where this file is stored. So if we want the disk drive to load the file, we tell it to load file 01. It looks at the directory entry, and here's the location of that file on the disk. And then the file name is the next 16 characters. So you can see here, this is Petsky for F, I, L, E. There's a space, 0, 1. And the rest again is padded with shifted spaces. That's A0. Then there's 3 more bytes here, which are zeros. Those are apparently only used by relative files, which I've barely ever played with. It's a special file type that can be used. I think you could use it for like a database, and we're not getting into that today. This is going to be long enough as it is. And then there's 4 more unused bytes. And then the next 2 bytes are 0. But when you're saving a file with save and replace, DOS actually temporarily stashes the track and sector of the other file in this location as a temporary buffer. And then finally, the last 2 bytes are the length of the file in blocks. So this one is 13 hex, which is 19 decimal, and the high byte is 0. So you can see the next 3 entries are just the same. Now here's an interesting little thing we'll just do. This is file 2. I'm going to change its file type from 82 PRG to 00. 00 indicates a scratched or deleted file. So let's save that. And we'll exit out. You see, the file has disappeared. The directory entry is still there, but it's indicated that it's deleted. And if we were to save another file, it would overwrite that location. But we could bring it back just as easy. So let's look here. Right here. And let's change that back to an 82. Save that. Actually, we don't even have to exit out to basic there. The file's back again. That's an explanation, not completely thorough, but I think it gives you a good idea of how a 1541 disk directory is organized. So now we're going to look at, here's Championship Wrestling again. There's our little wrestlers. So let's figure out what's going on here. One thing I noticed is down at the bottom, the bottom file is X, and then there's an HS file that was there for a bit. It's gotten overwritten now. But I think that's a clue where we should look, because the directory seems like it's printed normally until it reaches that point, and then the animation starts. So we'll load the beginning of the disk here, and we can see that the BAM has almost no blocks available at all. And you see here, this is the Kraken group, put XS, February 19th. This is a recent release just a couple weeks ago. And the next, just looking up here, 12.1. So we're going to load 12.1 next. And here's a bunch of files, Championship Wrestling. You can see here's the directory. See, we can see some 82s. Those are the PRG files. Here's the file names. There's an E, D. Each of the file names has a letter at the beginning. But we have to go quite a ways into this directory before we'll start seeing what we're looking for. So yeah, the next block in the disk directory is at 12.4. So let's load that one. So the next one is 12.7. We're just scrolling through here, looking through the directory. We're up to file M now. You see? So, okay, there's files N, O, P, Q, R, S, T, U. The next one is at 12A. V, W, X. And a file called HS, and another file HS. So this is that score. That's the bottom of the main directory, 82, and actually a scratched file. That might be just there by mistake. I'm not sure that's doing anything. And then interestingly, here's a file 80. That's a deleted file, a DEL, which is different than scratched. Okay, and here's some funny business here. Okay, you see the track and sector for this file, this 8D, that's decimal 141, which is a shift return. And these circles here are hex 91, so that would be 145. Now, if you programmed in BASIC a bit, you've probably seen these circles before. So I'm just going to drop back out to BASIC. Okay, normally I can just cursor around, left and right, up and down. If you type a quote, the computer goes into special quote mode, and now if I press cursor right, it shows symbols. If I cursor left, cursor up, cursor down. If I even try to clear the screen, it shows a heart on the screen. And now the way out of quote mode to escape from it is actually hitting Shift Return. And you see right here that when I press cursor up, it made that same circle. So these are some pretty big clues. And when I did a cursor left, it makes these lines here. So this is a very big clue here as to what's going on. Let's look at listing again. Looking at our disk. Here's a shift return. Here is a cursor up, 2, 3, 4, 5, 6. And these are cursor lefts, 1, 2, 3, 4, 5 of them. And another shift return, and then some A0s, which are just the padding to bring it up to 16 characters. What this directory entry is doing is actually pretty simple. When the Commodore is printing out the directory, it's just doing a print statement, and normally those are well-behaved characters, but if you shift return, it actually breaks out of the quote mode, and the print can start moving the cursor around. Essentially what's happening is the file name is a bunch of cursor movements that move the cursor up and above the listing, and then they start showing regular directory entries again. So there's actually 2 of these directory entries that move the cursor up from down near the bottom of the screen, about 6 lines up, and then another 6 lines up. And we're just going to take a look at the last couple entries here. So actually looks like there's 3 of them. Let's look at entry 6. Okay, so the next block we're going to load is 12D. And let's take a look at that. Okay, and so what we have here are some regular PRG files. And if you recognize these, they're kind of spread out, but what these are those little wrestlers. Like there's their heads, their arms, their legs. And then there's another one of these cursor movement file names. The screen is getting drawn from top to bottom. It draws the wrestlers, and then the cursor gets brought back up into the high end of the directory, and that's ready for another frame. There's the wrestlers' heads again. And I think you can see now how it's working. All it's doing is printing multiple directory entries over the old ones, and it's all synced up, lined up, so that the animation plays out. And then when it finally, it just finishes the directory once the animation is over. Okay, so that's the secret. It's actually not all that complicated once you know enough about looking through the disk directories to figure out how it works. So, not just happy with that, I want to try and make my own. So I'll just restart the computer here. So here's my disk. I'm just going to format this again. That was the disk we were playing around with. Disk TD. The way I approach this, I ended up writing a little basic program. I'm going to go through it with you now that generates one of these, an animation disk. So I'll explain it line by line, and we'll run it and we'll see the result. Again, it's not going to be a wrestling match. I'm actually going to make it do a very simple little scroller. Well, you'll see how it works. So the first thing we're going to do is a save command. 5, 6, 7, 8, 9, 10, 1, 2, 3. And yes, you actually can use the save command within a program. It's a strange one to use because it just saves the program that you're writing programmatically. Now, I can't think of many times you'd actually want it, but this time I do. To do this animation, we have to generate a lot of file names. I can't think of any easier way to do it than to write a program to create all those file names. And all I'm doing here is a little tidy divider just to make our display look a little bit nicer. It doesn't really matter what we put here at all. Next, we're going to just define the string that I want to use in the animation. It's just like a little kind of scroll text. And what I'd like to do is 8-bit show and tell, but because it's got to be a file name with a limit of 16 characters, that's actually too long, so we have to truncate it down, or, well, not really truncate it, chop it down to that. Kind of especially bugs me out there's no hyphen there. But anyway. And next, we're going to define string with 16 blank spaces in it. And the reason we're doing this, I only just discovered this when I was writing this program. There's a space command, which I thought would be handy. Like, for example, if I want to print 5 blank spaces, and then, some string like hello. See, it works in a print command here. There's 5 blanks. But even though the programmer's reference guide says that space is a string function, it actually isn't. It actually doesn't return a string, because if we just try to do something like a string equals SPC5, you would expect that this would work and create a string with 5 blank spaces in it, or with 5 spaces, but instead you get a syntax error. And I guess that's why SPC doesn't actually have a $sign included in it. SPC, it actually thinks that's a variable with an array. I guess I can prove that by going a string with hello. You see it didn't print any blank spaces in front. So SPC is actually just a function that can only be used in print statements. Okay, that was a long diversion. And my point is that instead I'm just going to create this S string full of blank spaces, and we're going to use part of that to quickly make the blank spaces I need for this program. Let's continue on here. Line 40 is going to be uString. Here we're going to define that string that we saw the magic file name that wrestling directory animation was using. We're going to recreate that in BASIC. The 8D is going to become a character string 141, and that's the shift return. And then 1, 2, and 3, that's cursor up. And then we're going to fill up the space with cursor lefts. 8 of them. 1, 2, 3, 4, 5, 6, 7, 8 of them. There's probably other ways of handling this. I'm just imitating what they did. Again, the wrestling. The cursor left seems to be a way of just wasting space without actually printing anything. And then we're going to add another character string 141, which is another shift return. And then a couple 160s, which are the shift spaces as padding. And so if we count them, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 characters long. uString is 15 characters, and we're saving one of the 16 characters we need for later. I'll explain that more later, but basically we have to make each file name unique. And if we just print uString as a file name, we'll actually get an error as we try to save that file, because Commodore DOS checks that each file name is unique. Anyway, we'll get into that more later. You'll see the effects of that later. Okay, and now we're just going to do simple for loop for x equals 0 to 16. Our animation is going to be 17 frames long, and we're just using one line per frame. It's just going to be a single line of text, and so it's going to have 17 states. The first one is going to be a completely blank string, blank file name, and then there will be 16 as our string of 8-bit show and tell slides in from the right to the left. It's going to be exciting. And then we're just going to print X. And the only reason we're doing that is just for our own information as the program runs. It's going to actually take a while to do all this work. So it's just something for us to look at to make sure it's still working and hasn't failed. Line 70, L string equals left string, S string, comma, 16 minus X. So what that's going to do is print from 16 down to 0 spaces at the front of our file name. And then what we want to do is kind of the opposite of it. The left string of N string. Actually, don't know why did I name that L string? I don't know, because it's left. It's using left a lot. L string is going to be 16 characters long. At the first time it's going to be 16 spaces, and then 0 of N string. N string is our name. Left string is a function that just returns X characters from the left of the string. So from S, it's going to take the leftmost 16, and then on the first step, when X is 0, it's going to take none. And then next time through the loop, when X goes up to 1, then it's going to print 15 spaces and 1 character worth of the name, and so on. 14 and 2, 13 and 3, you get the idea. Okay, now that we've generated the line name, I guess maybe that's why I called it L string, and I'm going to save that file, which will be unique because the animation is changing every frame. If X is less than 16, so every time But the last step, we also want to save uString, that's the up animation, plus character string 65 plus X. And again, we're saving that to device 8. This is creating a second file name. For each step, we're going to print the animated name, and then we're going to print the special file name that will do the cursor movement for us to loop the animation. But because it needs to be a unique file name each time, we're tacking on this character string returns a Petsky character. 65 is the letter A, plus X, print an A on the first step, then a B, then a C. I wish this wasn't really necessary, but I couldn't figure out a way in BASIC around this. And the reason I don't want it on the last step is that I don't want a cursor up at the end. After I print the last line of the animation, I want to just finish the directory and not cursor up again. And then 100, we're just going to go next, and that will do the next step of the for loop. Line 110, I'm just going to save another file name here, 123, and I'm going to do 10 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, comma 8, and that's just echoing line 10 way up here. It's just doing this little pattern, this little design in the directory up above, and then down below. Okay, we'll take a look at that. Does that look good? And we'll do the directory. Looks fine. Alright, we're going to run it and we'll see. Okay, and this is going to take a while, so I'm going to fast forward this section. It's got to write, I think it's about 35, 36 files to the disk, and that takes a while. Yeah, this has actually taken a minute or two. I hope I didn't make any mistakes. Yeah, this is taking a long time. Getting there. Oh, finally. Lost track of the time. I think that was about 4 minutes. But hey, it's better than doing it manually. Well, here's the moment of truth. Is it going to work? Woohoo! Now, it was slightly ugly. Let's look at that again. If you just focus on this part here, this line, it looks pretty good. One more time. Yay! So that's 34 files, but it looks just like 3 lines worth. That scrolls in there. Now, the one ugly, well, there's 2 ugly artifacts. There's this PRG here. That's actually the leftover from one of these, from the line that does the scrolling. On the other example, on the wrestling one, it showed DEL there, but that's something nicer to look at. And I'm not really sure how to get around that. If you guys have suggestions, or even better, if you want to improve my program, please do. But what we can do is fix up this ugly, where there's this P here, and as we do the directory, it shows ABC. Now, we can eliminate that. Unfortunately, it's pretty tedious. I suppose I could write a program to do it, but I don't really feel like doing that. So one thing we could do is just load in the directory. Okay, and here's the A, and so you change that to an A0, and so on. Basically, we locate each after the 2 A0s. Now there's the letter B, change that to an A0, and you skip over, this is the animation line here, the 8B, but the C we want to fix, A0. Okay, and then we can save that to disk. Make sure you get the right one. Let's do a directory and see how that's looking so far. And you see how if you look up in that top left corner, the A, B, C, and D are, the A, B, and C are fixed now. Or maybe this is slightly easier. I'm going to reset the computer here. So maybe easier, I'm going to load up here an old program that some of you might know, Fast Hack'em. And option E is a sector editor. Okay. And I'll put my disk in. This is another way, maybe more user-friendly than using the monitor we've been using so far this episode, but at the same time, I don't like how everything's just in decimal. I don't like how things are laid out so much, but it has some nice features. Like if you move to the top left corner and you look down below where it says position 0, byte 18, well, that's the track, and there's the sector. 18.1, so you just go jump, and there's the files that we just edited. So we already did 18.1, so now I'm going to jump again, and it automatically goes to 18.4, so that's convenient. I like that part of this editor. And now we should be able to find, so there is the D, and we can use the @ symbol to change byte, so it has the menu down the bottom there. And we're going to change that to a 160. The 160 is one of those shifted spaces. And so we can go through here, and maybe this is a little less tedious. There's the E erased. Here's the F. I think this is actually programmed in BASIC, so it's actually really not very responsive. There's F. Okay, and we're going to rewrite the block. Are you sure? Yes. Okay, now we're jump to the next one, 18.7. And there's an H to do. Okay, so I'll probably skip ahead. This is probably too boring for you guys. Is it going to be over soon? And P. Rewrite, yes. Okay. I hope that's all of them. We'll just reset the computer again here. Now let's do a directory. Oh, I missed one. I think I missed the G. Just hit return to get to 18.0. Jump. Jump. Oh, there it is. Did you guys see that? Rewrite, yes. Okay, I hope this is it. Yay! And just one more thing. It's been brought to my attention that there have been other animated directories before. A couple years ago there was one that's even more impressive, but I'm not going to figure out how it works today. But we will look at it. This one is called Directory Karate Plus from 2017, and it's by Scott of Antarctica. Check this one out. And there you go. In full color, full screen. And I guess on purpose it freezes at the end. I don't know. Anyway. Pretty amusing, that one. Full point. Okay, thanks for watching. We'll talk to you next time.